This video introduces IS2R, reinforcement learning of robotic policies in tight human-robot interaction loops. Here's an example of the end result of IS2R. Our goal is to leverage the power of simulation to train robotic policies that are proficient at interacting with humans upon deployment. We focus on the task of cooperative table tennis, where the objective for the robot is to play cooperatively with a human player for as long as possible. The main challenge is how to gather examples of a human interacting with a physical robot in order to model human behavior in simulation, without already having a robot that is able to interact with a human. Iterative Sim2Real, which we call IS2R for brevity, attempts to address this. IS2R bootstraps from a simple model of human behavior and alternates between training in simulation and deploying in the real world. We start by collecting an initial dataset of human behavior without the robot doing anything. This initial dataset is used to create an initial human behavior model, which in turn is used to train a policy in simulation. When the policy has converged, we transfer the weights to the physical robot. Initially, the policy can successfully return balls, but struggles to sustain cooperative play. Then, the policy is fine-tuned on the real robot for a number of parameter updates. All human interaction data from fine-tuning is added to the existing human interaction data. The human behavior model is updated, and the policy weights are transferred back to simulation, where training continues using the latest behavior model and the latest fine-tuned model from the real world. Then the policy weights are transferred back to the robot for another iteration of fine-tuning. And the process is repeated until the human behavior model converges. We evaluate IS2R by training 5 different policies, one each for 5 non-professional players of varying skill levels. At the end of training, IS2R policies can rally for 22 successive hits on average. And they can often sustain much longer rallies. We compare against a baseline S2R approach, in which we train in simulation just once, and then fine-tune in the real world continuously for the same amount of time as IS2R. For the majority of players, IS2R significantly outperforms the S2R baseline. However, for one player, S2R performed very well. Here, we show some failure modes of the policies. For example, due to false positives in the vision system, or some balls hitting the net, and occasionally some system failures. Policies learned using IS2R can often generalize to new players in a zero-shot fashion. Here, a player who was not involved in the training of the policy in any way can sustain a rally with the learned policy. In comparison, policies trained using S2R alone are often brittle and unable to sustain longer rallies. Thank you for watching. For more information, please see our paper.